Hi guys, welcome to the second video in a series of videos going over all the commands and techniques needed for Programming 1. In this Unit 2 demo, we're going to be going over all of the stuff for Unit 2, including inputs as well as variables, as well as touching in on a couple of things to review from Unit 1. Now as we look at Blitz, again, a reminder here that when we see this untitled, that we need to make sure we save our programs. We're going to be saving those into our folder under the correct heading. Okay. So when I click to save this guy, I'm going to remember to save mine using the initials as well as the unit and the problem. Okay. After that, I'm creating the header, which is going to be comprised of my comments, giving my name, programming I am in, and the unit and problem. After I've created my header, I'm going to begin creating the graphics menu. And the graphics command is going to have the width of my graphics window, followed by the height and my color depth. Now in Unit 1 we talked a little bit about variables, but the variables that we talked about were in correspondence with fonts, where we would load information into a variable name that we would have all that font information on. When we talk about variables for Unit 2 and going forward, most of that information is going to be data information in the form of either numbers or text. So we have several different variable types that it's important for us to understand first. Now keep in mind that as we do variables, that Blitz is going to let you know that you have a variable by keeping your text white. So the first variable type that I want to show you guys is going to be the integer variable type. Now this would be something like people. Okay, so you'll note that people stays white. Blitz is telling us that we have a variable in there. Now the name of this variable is obviously people here, and it is an integer type of variable. This is really important because integers are going to only have whole numbers. It would be really a bad thing if we end up with 2.7 people. We always want to have a whole number of people. So people is going to be a perfect example of something that should be an integer value. Now I can hard code this thing by saying people equals 5, and then if I want to print this to the screen, I can print there are put my wait key end. And now if I run this program, you'll see that when the code has gotten into where it has found people here, it has replaced that with the value that we have in 5. Okay? This process right here is known as conjugation, and this may be a term that you would have heard in one of your either Spanish or French classes in reference to verbs. Okay? Just like if you were conjugating a verb in Spanish class, where you'd be adding something to it, our print statement is having information added to it in the form of the variable people as well as this next string here. Okay, so again, this is an example of an integer variable. It's keeping track of whole numbers only. Now there are many times that we would want to use a variable other than a whole integer number. For instance, if we were talking about calculating areas or doing division, or if we were talking about cost. So if I'm using the variable cost here, in order to denote that I want to keep track of decimal places, I need to include a pound sign or a hashtag after the variable. This creates what's known as a float variable, and this variable's name then would be cost float. After I've got that, if I'm going to hard code in some data in here, I can say cost is 99 cents, and if I want to print, I can print that soda costs and put cost float in here, showing me that that soda costs 99 cents. So those are going to be our two main numeric variable types. Now, we can also store information in the sense of text. This information is going to be what's known as a string variable. So if we have a name, I'm going to denote that this is now a string variable by including the $sign afterward. So this string variable becomes name string. If I was to include this guy, and I say, for instance, just name string equals Josh, and I print Josh, or print name string here, you'll see that I'm going to not get exactly the most desired result. That's because when Blitz is looking at this, we see that Josh is still in white, telling me that this is a variable. So Blitz is looking for an integer variable named Josh, which obviously has no value. So when we go to print name string, we get this 0 in here. It's important to note that if you're hard coding a string variable, you need to put quotes around this. Now when I run this, I get the more desired effect of printing out my name. So those are going to be our three main variable types, and we can hard code these just like we have in Unit 1. However, Unit 2 is all about giving more variability and user control of these programs, and to do so we need to include inputs. Inputs allow for the user to simply put this information in. So rather than actually hard coding this name, we can have an input in here, followed by parentheses, and a prompt, what is your name? Closing off my parentheses, if I print this out, you'll notice that Blitz comes here to ask me what my name is. I put in Josh, and it will print out my name. You'll also note that this input is followed immediately by the text you're entering, so a lot of programmers will include a space in their prompt string in order to provide the user with a little bit more room for doing their input. Now within the Blitz language, we can manipulate strings in a couple of ways. The first way we can manipulate strings is through the use of the upper command. The upper command is simply going to take whatever we have within the parentheses and convert it to an uppercase. So I'm going to be replacing namestring with the uppercase version of itself. What is your name? Josh Keller. And you'll note that it capitalizes the entirety of the string. Similarly, if I was to convert this to the lower command and run it, it does not matter how I capitalize things. It is going to convert everything into a lowercase. This will be very helpful later down the road as we start comparing strings with each other. Now you'll also note that the input is in the upper left-hand corner of our graphics menu. When we are printing information to the screen, if we want to find a location other than that upper left-hand corner, we would use the text command. Unfortunately, there's not a clear means of doing so within the input command. So we need to introduce another command if we want to locate our input in a different spot. That command is the locate command, where I'm going to simply say locate and then declare the location that I want my input or the following command to be ran at. And let's say we go to input this at 300, 400, run my command, and my input command is now over 300 pixels and down 400 pixels. And I type in my name. You'll note that the print command following this input returns back to x equaling 0. So while it will keep track of the next line available, it loses this x coordinate. Therefore, if I want to print this information in a different spot other than immediately following the input and on the far left boundary, I need to introduce the text command for these guys as well. Finally, there is one more command that we want to introduce in Unit 2, and that is going to be the oval command. Now, the oval command is going to work quite similar to the rectangle command in that we need to declare a start point and an end, and a width and height. If I was to want to put an oval around this text information here, you'll note that if I start at 200, 200, just as my text does, and let's give this a width of 200 and a height of 50, and make it hollow, that in doing so, my oval is not going to be anywhere around my name right here. That's because with the oval command, its start point comes over and down, but then that is going to be, the oval is going to be drawn within the rectangle associated with that point. So the oval will never actually truly touch my start point. So if I want to draw this oval around the name, I need to move it further to the left and up the screen. Playing around with these values, I can get this thing to be centered a little bit more better, but you can understand that the oval command, you're going to have to do a little bit of trial and error or some math in order to orient your oval in the desired location. That should give you enough information now to complete all of the problems in Unit 2. If you have any questions, feel free to review and rewind this video, pausing along the way if need be, and good luck with your programming.